Alright, let us continue. The next topic is preparation of hydrocarbons. How do we prepare these hydrocarbons? Remember, whatever methods we'll be doing now, these are general methods. That means if you know how to prepare a particular alkane, you should be able to predict rest of the alkanes also. So from first method is from unsaturated hydrocarbons, and as you know, unsaturated hydrocarbons can be alkenes or alkynes, so it can be prepared from both of them. The next method is from haloalkanes or alkyl halides. Alkyl halide is IUPAC name for the haloalkanes, that means alkane with a hydrogen. And the third method is from carboxylic acids, and the method is called decarboxylation. So let's begin with the discussion. The first one from alkenes and alkynes. As you know, alkenes having CnH2n as the general formula, and they have a carbon-carbon double bond. We call them unsaturated hydrocarbons. Now if we add a molecule of hydrogen across the double bond, remember, out of these two bonds between carbon and carbon, one is sigma, the other is pi, and the sigma bond is stronger bond which cannot be broken easily, but pi bonds are however very weak, which we have done last year in chemical bonding chapter. You know that pi bonds are formed by sidewise overlapping of p orbitals. So when we add hydrogen, we break the carbon-carbon bond, and as a result what happens? Each carbon has a free hand now. So this carbon will take up one hydrogen, this carbon will take up another hydrogen. But this reaction requires a catalyst. And which catalyst is used here? The catalyst used here is either nickel or platinum or palladium. If you check the position of these elements in the periodic table, you will find them, they are all appearing in group 10 in the transition metal group. They all one below the other, so they have similar properties. So when these carbons, they hold each other, the hydrogens, they pick up one hydrogen, and they get converted from unsaturated, they get converted to saturated hydrocarbon, that is alkane. So ethene forms ethane. If you take propene, propene will form propane. If you take butene, butene will give you butane. So this way, if you know how to prepare one, you can predict the preparation of the rest. But one disadvantage of this method is you cannot prepare methane by this method, because there is no unsaturated hydrocarbon with one carbon. So let us take another example where our starting material is alkyne. In alkyne, what we have? Alkyne, we have two double bonds, right? So since there are two, there is a triple bond, one is sigma, the other two are pi. So they can take up two hydrogen atoms. So when the first molecule of hydrogen is added, they get converted to alkene using the same catalyst. And in the second step, another molecule of hydrogen gets added up and they get converted to alkane. So for alkynes, it is a two-step reaction. For alkenes, it is a one-step reaction. Now let us see from haloalkane. There are two methods under haloalkane. One is called reduction and the other is called Wood's reaction. In reduction, what happened? Zinc and HCl is treated, where zinc forms zinc chloride and liberates hydrogen gas. As you know, zinc appears above hydrogen in the activity series, so it has the ability to replace hydrogen from its acid. Now this hydrogen which is formed here, at present, in the beginning, it doesn't form in the molecular state. It comes out as atomic hydrogen, which we say nascent hydrogen, and it is a very, very reactive hydrogen. So we do not prepare hydrogen beforehand, we prepare it in the system. So we call it in situ, INSITU, in the situation itself. So CH3Cl, which is chloromethane, when treated with zinc chloride and HCl, which generates hydrogen molecule. You can see you are allowed to draw boxes in the chemical reactions of organic, and what you get is methane. So, the speciality of this reaction is as many carbons you have in the reactant, that many carbons you have in the product.